Assalamualaikum and selamat sejahtera. My name is Muhammad Hilman bin Muhammad Najib and my matrix number is B0822100170. I will present for my part, which is introduction of transfer function. Transfer function is a fundamental concept in engineering control system. Engineering and signal processing, it is a mathematical representation that relates the output of the system to its input, typically in the frequency domains. The transfer function provides a concise description of the system behavior and allows engineer to analyze and design system using mathematical techniques. Transfer function H omega of a circuit is the frequency dependent ratio of a phasor output Y omega an element voltage or current to a phasor input X omega source voltage or current. So we can understand that this transfer function is variation in circuit behavior with change in signal frequency and may also be considered variation of the gain and phase with frequency. We also know the transfer function is input over output. Next is calculation. Firstly, we convert transfer function to a standard format of transfer function to get bird plot. Given transfer function is 15 j omega plus 2 over j omega plus 4 j omega plus 10 power of 2. After that, we factorize the denominator and it will become 4 times 100. Next, we simplify the 15 over 400 to 1 over 8. Next, change the transfer function to the magnitude plot. H decade 20 log 1 over 8 plus 20 log j omega minus 20 log 1 plus j omega over 4 minus 14 log 1 plus j omega over 10. For our phase plot is theta equal 19 degree minus tangent omega over 4 minus 2 tangent omega over 10. Next is zero and poles. What is zero and pole? The context of transfer function, a zero refer to value of the impedance variable, which is the numerator at the transfer function becomes 0. To find 0, equal each term in numerator to 0. Find j omega per instance. 15 j omega equals 0, j omega equals 0. There are no 0 in this function since the imaginary component is non-zero. To find poles, equal each term in denominator to 0. Find j omega. Since the power of j omega plus 4 is 4, the multiplicity is 1. J omega plus 4 equals 0, j omega equal negative 4. Since the power of j omega plus 10 is 2, the multiplicity is 2. J omega plus 10 equals 0, j omega negative 10. Poles in this transfer function negative 4 with multiplicity of 2 and also equal negative 10 with multiplicity of 2.
My name is Muhammad Kifan bin Muhammad Ali. The matrix number is B0822100500. Today I will present about this question. My question is 50 j omega over bracket j omega plus 4 bracket and bracket j omega plus 10 squared. So about this question, first step we can solve the question. So we become to 50 j omega over bracket 4 j omega plus 1 over 4 bracket 10 and bracket j j omega plus 1 over 10 and 10 j omega over 10 plus 1. We become to cut multiply 4 multiply 10 and multiply 10 and they become 400. So the next step, we got a 0 at origin. So and j omega over 8, j omega over 4 plus 1 and j omega over 10 plus 1. And we know j omega is 0 at origin and 8 is k, and j omega over 4 plus 1 and j omega over 10 plus 1 is a simple pole. So this answer is a we can see this graph. First of all, magnitude plot. This 0 at origin, 20 log j omega, this line, negative 20 and up to straight line. We must cross a 1 in the below dB per decade. So next graph is 40 log 10 j omega 10 plus 1. Why 40 log j over 10 plus 1? Because this question become 50 j omega plus 4 and j omega plus 10 squared. So we change the question squared to 40 log. Okay, this is a simple pole. So the next graph is 20 log j omega over 4 plus 1. This is a simple pole. And the next one is a gain. Gain is a straight line. How to calculate gain? K is 20 dB bracket 8, and we must, the answer is negative 18. So the next we go through the phase plot. This is graph the phase plot. Okay, first of all, we can talk about j omega. This is 0 at origin. This is we must add 90 degree the constant. The next question, this gain, k gain. So we must see this we add the constant, the straight line, to 0 degrees. So the next graph, simple pole, j omega over 4 plus 1. This is negative 90 degrees. 90 multiplied by that n degrees. So the next simple pole is j omega over 10 plus 1. The negative 118 multiplied by that n degrees. This graph, like the same this magnitude plot, dB decade 0 and 90 degrees and 118. DB decade, let's say the magnitude 0.1, 1, 10, 100 and 1000. Alright, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Ilman bin Muhammad Hasbi, matrix number B0822100011. So I will explain to you how to plot the phase bolt plot. So from the transfer function we have here is 1 over 8 j omega over 1 plus j omega over 4 times with 1 plus j omega over 10 power of 2. So to plot the phase bolt plot, we have to transform this into phase angle. So first we have here is the 1 over 8. 1 over 8 is K. So the phase angle for K is 0 degree. So we just plot it on the x-axis 0 degree. Next is the J omega. J omega here is a 0 at origin. So the phase angle for 0 at origin is 90 degree. So we just draw a straight line at 90 degree. For 1 plus j omega over 4, it is a simple pole. For simple pole, it will remain 0 until it reach P over 10. So we have P equal to 4, then P over 10 is 0.4. So from 0.1, it will stay at 0 degree until 0.4. Then at 10P1 equal to 40, it will reach 90 degree here. So from 0.4, we drew line until 40 and negative 90 degree. Because it is a simple 0, it will go down. Next, for the 1 plus j omega over 10 power of 2, since it has power of 2, so the slope will be double. So from we have P equal to 10, P over 10 is equal to 1. So it will move from 0.1 until 1, 0 degree, and then 10P2 equal to 100. It will shift into 100, negative 180 degree at 100 because it has power of 2. Okay, so next, to complete the phase bolt plot, we have to combine all the plotted graph. So we divide the graph into parts from point to point. So from the first point 0.1 until 0.4, we have 4 plotted graph. There is the green one 90 degree, we have the yellow one from the simple pole, the purple one from the simple pole too, and the red one from the K. But it is all 0 degree, so we plot from a straight line from 0.1 until 0.4 for 90 degree. So the next point from 0.4 until 1, it has the two significant graph, that is the green one and the yellow one. So the green one is 90 degree and the yellow one is it drops down negative, it drops down for 18 degree. going 18 degree because one division is 9 degrees. So we are from 0.4 until 1, it only has two divisions, so 9 times 2 is 18. So 90 degree minus 18 is 72 degree. So for the next point, we take from point 1 until 40 because there is no changes from these 2 points, between these 2 points. So the graph that we take into consider is the yellow one and the purple one. The yellow one has a slope of uh, 90 or 72 degree because the from 0.4 until 40 we have 90 degree, but we only take from 1. We have to minus the balance here, and we have to add it to the slope of the purple graph. For the purple graph, we have 1 until 100, but we take into 1 until 40 only. So between this 40 and 100, it is 36 degree because it has 4 divisions. So 9 times 4 is 36. So 180 minus 36 is 144. So to plot this, we add these two graph together. That is 72, negative 72 plus negative 144, and we will get 216 degree, negative 216 degree. But then to find how many divisions we need to plot, we must divide it by 9, and then we got 24 division. So from here we count until 24 to the bottom, and then we plot it at 40, and we get here. So for the next point from 40 to 100, we have already calculated it is negative 36 degree, so we just plot it from 40 to 100, and then the rest it will remain negative 180 degree. That is all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hirzan Zufairi bin Muhammad Yusof. My matrix number B0822100053. I am from BEEI student, section 1/1. Okay, now I want to explain about how to obtain transfer function from corresponding both plot. Okay, first one we can see our corner frequency omega equal to 100 and 1000 radians. Okay, from the board plot, now I want to explain about the analysis of obtaining transfer function. The board plot in this graph had three distinct segments that was a straight line of h dB equals to 40 for 0 omega 100. A simple pole graph with slope of negative 20 dB over decade for 100 omega 1000. A simple zero graph with a slope of positive 20 dB over decade for omega 1000. So, to derive the transfer function, we analyze each segment of the graph. The straight line segment indicated as a constant gain, which we determine to be 40 dB. The pole segment with a slope showed of 20 dB over decade as a simple pole at omega equals to 100. The zero segment indicated a slope of positive 20 dB over decade as a simple zero at omega equal to 1000. By combining all of these components, we obtain that the transfer function h omega equals to 100 multiplied by 1000 plus j omega over 100 plus j omega. Okay, now I want to explain about the method of obtaining transfer function. How to find gain. Okay, the way how to find gain is 20 log 10 k equals to 40 dB, which is our constant gain. So, log 10 k equals to 40 divided by 20. So, k equals to 10, the power of 2. And k equals to 100. For the simple pole with slope negative 20 dB is equal to 1 over 1 plus j omega over 100. And the simple pole with slope positive 20 dB equals to 1 plus j omega over 1000. Okay, for the transfer function equals to 100 multiplied by 1 plus j omega over 1000 multiplied by 1 over 1 plus j omega over 100 equals to 100 multiplied by 1 plus j omega over 1000 over 1 plus j omega over 100, and then equals to 100 multiplied by 1000 over 1000 multiplied by 1 plus j omega over 1000 over j omega over 100 multiplied by 1 plus j omega over 100, and then equals to 100 multiplied by 1 over 1000 multiplied by 1000 plus j omega over 1 over 100 multiplied by 100 plus j omega. Okay, and then 1 over 10 multiplied by 1000 plus j omega over 1 over 100 multiplied by 100 plus j omega. So the final equation we get 10 multiplied by 1000 plus j omega over 100 plus j omega.
Next, I will present to you the discussion for this assignment. In this assignment, we conducted an analysis of the given transfer function and generated the corresponding board plots. Our analysis involved breaking down the transfer function into its individual components by calculating the magnitude and phase shift at different frequencies. By plotting these values, we obtain the magnitude and phase board plots. By examining the provided board plot, we were able to deduce the necessary equations for gain, poles, and zeros, and then enabling us to derive the transfer function. In summary, the transfer function is a valuable mathematical tool that allows us to understand how a system responds to different frequencies. Its applications span various engineering and scientific fields, facilitating system optimization and performance enhancement.
Okay, for the conclusion, what we can say is transfer function is the way to find the frequency response of the circuit. The transfer function is defined as the ratio of output response of Laplace transform to the input response. Laplace transform can be used to provide the transient state behavior as the steady state behavior of the system. In other words, transfer function equals to output over input or C over R. The board plot typically involves in analyzing the gain and phase margin of the system. Besides that, board plot also can be used to identify resonant frequencies and other characteristics that might affect behavior of the system. Gain margin refers to how much additional gain can be added for the system before it becomes unstable. For the phase margin, it relates to how much additional phase shift might occur before a system becomes unstable.